We are starting our unit today on trigonometry. Some of the stuff, especially today, will hopefully be familiar to you because this is some things that you've covered in geometry. So before we get talking about too much, let's define the word trigonometry. Trigonometry, plain and simple, is the study of right triangles. We are going to be studying how to find the sides of right triangles, how to find the angles of right triangles, and eventually we are even going to be applying this to word problems in another lesson. So the most important part, though, is that we are working with right triangles. That requires that in your triangle, you must have a right angle. So if you look at our triangle over here, and you notice this little box here, hopefully from geometry, you remember that that's the notation for a right angle. So now that we know where our right angle is, the most important side of the right triangle is the side that is directly across from the right angle. And hopefully you remember in geometry that the name for that side is the hypotenuse. Now that side will never change locations. No matter which way I draw the triangle or turn it around, if you can find the right angle, you go straight across from the right angle and you will always have the hypotenuse. Now the other two sides of the triangle are dependent upon which angle you are focusing on. So this other little symbol right here, that symbol is called theta. Theta is a Greek letter, but it's the symbol that we use to represent angles in a triangle. When you are solving these triangles, the first thing that you label is your theta. Which angle do you want to be your focus? Because once you know where your angle of focus is, the side that is across from theta is always the opposite side. And so after you've now labeled the hypotenuse across from the right angle and the opposite side across from theta, the remaining side is always going to be called the adjacent side. So again, across from the 90-degree angle is the hypotenuse, across from theta is the opposite side, and the missing side is the adjacent side. Now you will see me use the following abbreviations. I will be using H for hypotenuse, O for opposite, and A for adjacent. Because in math, we tend to be lazy and we like abbreviations. Now, once you have all of your sides of the triangle labeled, there is a very important word that you learned in geometry that relates all of the sides of the right triangle. Hopefully, at some point in geometry, you learned the word SOHCAHTOA. Now, the spelling of this word is probably the most important part because it tells you what goes with what in terms of the right triangle. We have three important words that relate to trigonometry. The first word is the SO part of this. So when you're talking about SO, the SO part stands for, this is called sine. That's how you pronounce it. The sine of theta will always be opposite over hypotenuse. So S is sine, O is opposite, H is hypotenuse. That's the first of the three important trig functions. The next one is your COS. COS, stands for cosine. Yes, I expect you to use the word cosine. It's not cos, it's not cos, it's cosine. Cosine of theta is always the ratio of the adjacent side divided by the hypotenuse. Cosine, adjacent, hypotenuse. Finally, TOA stands for tangent of theta. Again, that was tangent of theta. And the tangent of theta is always the opposite side over the adjacent side. Tangent equals opposite over adjacent. So with all of this information that we just learned, we are going to be applying it to solving for missing pieces of right triangles. So I'm going to give you some steps to follow. So to solve for any missing piece of a right triangle, the first thing we do, label your angle with theta, and then label your sides of the triangle with O for opposite, A for adjacent, and H for hypotenuse. Once your items are labeled, then you need to choose the appropriate part of SOHCAHTOA and set up an equation. To know which part of this to use, it simply depends upon what pieces you know in your triangle. Once you've set up an equation, then you're going to solve your equation for the variable. Notice I haven't said anything about a calculator yet. Now, the final step of the process is to use your calculator. You don't touch your calculator until step 4. So then you use your calculator to find the approximate answer. And then this very important piece of the puzzle is huge. You need to make sure your calculator that you are using is in degree mode. I'm going to show you how to do that along the way. We'll talk about how to do that on my yellow calculators. If you have your own calculator at home, I encourage you to bring it in so I can help you do that as well with yours. So let's take a look at an example. We're being asked to solve for x. So if you notice, there are some pieces labeled on our triangle. First, according to our first step, label our angle with theta. Well, since this is the angle that has a number in it, that's my theta. So now that I have my theta labeled, I can label all of my sides of my triangle. Right angle points straight across to the hypotenuse. Theta goes straight across to the opposite, which means that is my adjacent. Now if you notice, the two sides that have numbers and letters there are this one and that one. Since O and H are the two sides that we know pieces of information about, we now come to step number 2. O and H means that we are going to use sine. So our equation is going to be the sine of theta equals opposite over hypotenuse. So let's plug in our 3 pieces. Sine theta is the number 25. O is opposite. That's the letter X. H, hypotenuse, is the number 15. So that is step number 2. We chose the appropriate part of SOHCAHTOA and we set up an equation. Now step 3, we need to actually solve the equation for our variable. We want x by itself. Well, the only way to get x by itself is to get rid of this 15. And the opposite of division is multiplying by 15 on both sides. Those will cancel. This is just going to stay right now, 15 sine of 25 equals x. So we now have x by itself. Now, step 4, you actually get to use your calculator to find the approximate answer. So, our calculator, there we go. So you're going to press your 15 first. So 15. Then you're going to press your sine button. It is right next to cosine. Then you're going to put in your angle, which was 25. And you should get an answer of not the right thing. So this is something that we needed to talk about. This little note right here was extremely important. You need to make sure your calculator is in degree mode. To be in degree mode, you have to press the mode button, and it should bring up this menu. Notice right here, this word degree needs to be highlighted. So I'm going to go down 2 and right 1, and I'm going to press enter. Now degree is blacked out. So I'm going to clear, and I'm going to try again. 15 sine 25. And now I get an answer of 6.3. And so I'm going to come back over here, and I'm going to go and say that x equals 6.3. And so we will make sure if you ever have any questions on your own calculator, bring it to school and we'll make sure that your calculator is in the right mode. So let's look at the next example. So what's the first thing we label? Our angle. Well, here's 42. So I'm going to put my theta right there. Now we label our sides. Right angle points to the hypotenuse. Theta goes across to the opposite, which means this side is your adjacent. So the pieces that we have information about this time are H and A. So H and A, here's H and A together. So we're using the co part, which is cosine. So our equation is cosine of theta equals adjacent over hypotenuse. So cosine theta is the number 42 equals the adjacent side is x, the hypotenuse is 6. Now we need to get x by itself, which means this dividing by 6 needs to cancel. The opposite of dividing is multiplying by 6. So we have 6 cosine of 42 equals x. So again, we're going to use our calculators. So 6 cosine 42 equals 4 point, and because this is a 5, that'll round to 4.5. So x equals 4.5. Okay, so hopefully you're thinking, oh, well, this isn't too bad so far. So get another example together, and then you're going to try one on your own. So again, we start with our labeling. Here's an angle, that is 55, so I'm going to put theta there. Across from the right angle is the hypotenuse. Across from theta is the opposite, which means that guy is your adjacent. The sides that we know information about are the hypotenuse and the opposite. So if you have O and H, O and H is again sine. So sine of theta equals opposite over hypotenuse. So the sine of 55 degrees equals the opposite, which is 9, divided by the hypotenuse, which is x. Now this is our trickier problem because it's going to take more than one step to get x by itself. This division bar we are going to get rid of, but the problem is you can't get rid of the 9 this time. You can only get rid of the thing in the denominator. So we're going to start by multiplying by x on both sides. That's going to get rid of your fraction. So now we have x sine of 55 equals 9. The problem is x is not by itself yet. Now we need to get rid of the sine of 55. Well, since this is multiplication, we're going to divide by the sine of 55 on both sides of the equation. Your calculator can do this tough part for you. Those cancel. So now we do have x equals. So we're going to type in 9 divided by the sine of 55. 9 divided by sine 55. And we get, so 10.98. So this 8 is going to make this 9 round up to a 10. So let's talk about what that means. So 10.98. So this is going to make this one go up to 10. But the problem is, the 1 has to get carried over here. So it really becomes 11.0. So this one is trickier because we had to first get rid of the x to the other side, then we had to move the sign to get our final answer. So you're going to try one on your own. Pause the video and try this example. Okay, so let's see how you did on this example. So theta is 20. Across from the right angle is the hypotenuse. Across from theta is the opposite. That's the adjacent. So you have h and a, which is cosine of theta, equals adjacent over hypotenuse. So cosine 20 degrees is 6 divided by x. So this is one of the more challenging ones. So of course you needed to multiply both sides by x. So x times the cosine of 20 equals 6. And then you had to divide by the cosine of 20. And you get x equals, when you put that in the calculator, you should have ended up with 6.4. So we're going to do another type of example related to these problems. But notice the directions are different. It doesn't say solve for x. It says solve for all missing pieces of the triangle. That means that you need to have a number in both corners and on all 3 sides. So, some things that might be helpful in terms of labeling. Okay, obviously, this is our theta, because that's the angle we know. I want to figure out what this angle right here is. I want to know what angle A is. Well, hopefully in geometry you learned that all 3 sides of a right triangle add up to 180. So to find angle A that I am missing, I'm going to take 180 degrees. I'm going to subtract the 62 that I know, and I'm also going to subtract the 90 that I know. 180, take away 62, take away 90, leaves you with an angle A of 28 degrees. So I'm going to put a 28 over here in that little corner. So now I have to pick one of my sides to start with. So I know this is the opposite. I'm sorry, I know that's theta. I know across from the right angle is the hypotenuse. I know across from 62 in theta is the opposite. And I know this side's the adjacent. Well, you pick. Why don't we go ahead and start with finding the opposite? So we know this is what we want to find, and this is what we have. So O and A make up the TOA. So TOA. It makes up that part right there. The TOA stands for tangent. So the tangent of theta, which is 62, equals the opposite, which is O, because we don't know it, over the adjacent, which is 6. So we're trying to solve for the opposite side. I'm going to multiply by 6 on both sides. So 6 tangent of 62 equals the opposite side, because those cancel. So type in your calculator 6 tangent 62, and your opposite side should come out to be 11.3. So I'm going to put an 11.3 right there. So our final side of the problem we need to solve for is the hypotenuse. So I'm going to really reach back to some of your stuff from geometry. If you have two sides of a right triangle and you would like to find the third side, you are not required to use trigonometry. You can use the Pythagorean theorem to solve for your missing side. So if you remember, the Pythagorean theorem was always a squared plus b squared equals c squared. Well, which one was the most important one in the Pythagorean theorem? The hypotenuse. The hypotenuse was always this one. Okay, this is where the hypotenuse is going. It doesn't matter which one of these you put which number. So a squared is going to be 6 squared, plus b squared is 11.3 squared, equals the hypotenuse, which is c squared. So 6 squared, of course you don't need a calculator for that, is 36. 11.3 squared is 127.69. Of course, next we need to add those two numbers together. So when you add those together in your calculator, you get 163.69. So then the final question is, how do we get rid of the square? Well, we've learned the opposite of a square is a square root. And yes, you may use your calculator. So if you type in your calculator the square root of 163.69, you will get C equals 12.8. So this guy is 12.8. We now have a number in each corner and a number on each side. So we are done. Pause the video. Try this one on your own. Okay, so let's see how you did. We know this is theta. Hopefully the first thing you found was this missing angle B. So B equals 180, take away 42, take away 90. So B ends up being 58 degrees. So our labels, across from the right angle is C, across from theta is O, and of course this is A. So we know we're using C, and this time I want to start with A. So if we are looking at SOHCAHTOA, we got C and A. C and A are the CA, which is the cosine. So the cosine of theta, which is 42, equals the adjacent, which is A, over the hypotenuse, which is 8. So we're going to go ahead and get a by itself. So I'm going to multiply by 8 on both sides. So we have 8 cosine of 42 equals a. Type that in your calculator. 8 cosine of 42 gives you that the adjacent is 5.9. Okay, so now that we can put down here 5.9, if you want, you can now, because we have two sides, we can switch to Pythagorean theorem. A squared plus b squared equals c squared. So a squared can be 5.9, but b squared we don't know. So we're going to put b squared. C squared we do know. That is your 8 squared. So if you use your calculator, 5.9 squared gives you 34.81 plus b squared. 8 squared is 64. Then, this time we can't add the two numbers. They're on opposite sides. So we need to subtract 34.81. And we get 29.19 square root both sides, and we get b equals 5.4. So our missing side over here is 5.4. And now we have all of the sides and all of the angles labeled. So the next thing we need to talk about, and this is the last part of the lesson, is what's called inverse trig functions. So vocab. Inverse trig functions are used to find the missing angle of a right triangle when you are given two sides. So there's 3 different inverse trig functions. There is inverse sine, which looks like this little symbol, inverse cosine, which looks like this, and inverse tangent, which looks like that guy. If you look at your calculator and you look above the sine button, you should see this symbol. These 3 symbols are above the 3 symbols you already have. And so the only thing that you need to know in order to use them is that you have to press second before you press sine, cosine, or tangent. So, in order to use these, most of this is going to look familiar. Label your angle with theta and label your sides. Choose the appropriate part of SOHCAHTOA and set up an equation. But now you have to use the appropriate inverse trig function. And then finally, use your calculator. And again, be sure your calculator is always in degree mode. So let's look at a couple of quick examples and then we will be done with this lesson. So if you notice, theta is already labeled. So since we have theta labeled, we're going to label our sides. Across from 90 is the hypotenuse. Across from theta is the opposite. And that is the adjacent. So we have O and H. So if we are doing O and H, we're using sine. So the sine of theta equals O over H. Well, here's the difference. We don't know theta. It's staying theta. O is 7. H is 12. So that is the second step. We chose the appropriate part. We set up an equation. Now we need to use the appropriate inverse trig function. I need to move this word to the other side of the equation because I need theta all by itself. So since this says sine, when I move it over here, it simply changes to inverse sine, and it attaches to the fraction. So when you move any of these words to the other side, they simply become inverse and they attach to whatever is there. So the way we do this in the calculator, okay, because we're ready for our calculator, we need inverse sine this time. So inverse sine is right above the sine button. I'm going to press second sine. You see the little -1? That's what we needed. And then it is attaching itself to 7 divided by 12. So our angle is 35 point, this makes that a 7. 35.7 degrees. So 35.7 degrees. And yes, I want to see you use degree symbols when you're solving for angles. Let's try one more together. Here's theta. Across from the right triangle is H. Across from theta is O, which means this is A. We have A and O. So A and O is over here for tangent. So the tangent of theta equals O over A. We don't know theta this time. We do know that O is 18, and we do know A is 13. So we want to take this word, whoops, didn't mean to erase it. We want to take this word and shift it over here to get theta by itself. So when it shifts, it becomes inverse tangent. And it attaches to 18 over 13. And you go to your calculator, and you press second tangent. So second tangent, and we're going to put in 18 divided by 13. And we get 54 point, that rounds up to 2. So theta equals 54.2 degrees. So, final example, pause the video, try this one on your own. Alrighty, let's see how you did. Across from 90 is H. Across from theta is O. That means that is A. So H and A mean cosine. Cosine of theta equals A over H. Cosine of theta equals A is 7 divided by H is 20. We want to move this word over here so that theta is by itself. It changes from cosine to inverse cosine and attaches to 7 over 20. Second cosine, 7 divided by 20 should give you an answer of 69.5 degrees. And that is the end of your video. See you in class.